Hi everyone. Welcome to this session. I'm just here to solve one question from linear algebra. Okay, that question was asked in Electronics and Communication Engineering Gate 2024, and many of us made a big mistake, while solving that question. That question was very simple. Okay, 2 by 2 matrix was given, and you have to just find the eigenvectors of that matrix. Okay, so in that matrix, one of the element was unknown. Okay, that parameter was basically k, right? Let us see the question and how to solve that question. Okay, and in this session, you are going to learn the spectral theorem as well, right? So, what is this spectral theorem? How can we use spectral theorem to answer the question? Cleverly, right? So let us jump to the problem. So this was a problem, and if you're going to apply your conventional method, you're going to waste your time a lot, right? Please keep this in mind. This is my statement, okay? And please remember that if you're going to apply the conventional method, that is a minus lambda equal to 0, writing the characteristic equation, then finding eigenvalues and then finding the eigenvector. It takes a lot of time since the k is unknown here, right? So whenever this kind of problem will be asked, always remember, okay, Dheeraj sir statement. You look at the structure of the matrix, right? Consider a matrix 1k to 1 where k is a positive real number. Okay, they have specifically specified here k is a positive real number. Which of the following is or eigenvectors of the matrix? So first of all, look at the structure of the matrix, okay, and think about some value of k, okay, and you might get some special kind of matrix that you learn in linear algebra, right? So you notice here is that below the diagonal, if you look at the diagonal here, below the diagonal, okay, you can say principal diagonal, okay, there is a element 2, right? So if you're going to take k equal to 2, okay, so this matrix will become the symmetric matrix. Okay, so always try to obtain some special matrices, okay, that can optimize your problem, right? That can help you get the answer very quickly, okay? Since it is a 2 by 2 matrix and k here is not known, okay, so you can make assumption here the k is equal to 2. Why we are taking k equal to 2? Because so that the structure of the matrix will become the symmetric matrix, okay. And if the matrix is symmetric, okay, if the matrix is symmetric matrix, okay, so according to the spectral theorem, what spectral theorem says that, remember that, see this matrix, let's say this matrix is A, okay, and we have been given 1k 2 1, right? 1k 2 1, okay, and we have to find the eigenvector of the matrix. So I'm just going to bypass all the steps that you have learned in the classroom, needless to apply that, okay. During the gate examination, please remember why they have given this kind of question. Just they want to test whether you know the structure of the matrix or not. There are some popular matrix like the symmetric matrix, the rotation matrix, the permutation matrix, the orthogonal matrix. Okay, there are different types of matrices, right, that you should always appreciate. Okay, identity matrix, diagonal. Okay, there are different kind of matrices which are very useful. Okay, understand? So this is a matrix which is given, and if you start solving this question, okay, conventionally, you might get stuck somewhere and you might waste your time. I wasted nearly 10 minutes in this question and I was not able to solve this question. Let me be very honest with you. Despite I teach linear algebra, okay, and that was one of the biggest challenge, biggest mistake we do and we did. देखो, गेट एग्जामिनेशन के दौरान हमें समझ में नहीं आता हम क्या करें. वी नो, वी हैव सी ऑफ नॉलेज, धीरज सर हैज like I have done many problems on linear algebra. I taught linear algebra to larger audience, but still during the gate examination that concept should come into in your mind कि अच्छा 1k 2 1, अगर हम k इक्वल टू 2 ले लेते हैं तो ये मैट्रिक्स क्या बन जाएगा? सिमेट्रिक मैट्रिक्स बन जाएगा. चलो ठीक है. सो यहाँ पर क्या करेंगे? चूज cleverly k equal to 2 so that A is symmetric matrix. A क्या बन जाएगा, सिमेट्रिक मैट्रिक्स बन जाएगा, ठीक है. The moment you choose k equal to 2, now you might may be thinking, sir, why we are taking k equal to 2? Why not k equal to other value? See, if you're going to take k equal to 3, k equal to different value, right? First of all, k must be positive real number, right? It should not be negative real number. It should be positive real number, right? Hmm? So why not you should take k equal to 2? Because this matrix is going to become, okay, the symmetric matrix. That is kind of a special matrix, okay, that we want always. We always discuss, in whatever factorization decomposition we discuss, right? Everywhere we appreciate orthogonal matrix, the symmetric matrix, the rotation matrix, the permutation matrix. Okay, there are different types of special matrices, right? And they have a special type of eigenvalues and eigenvector associated with that. So first of all, in the gate examination, whenever the matrix question will be given, you have to just look at the structure of the matrix first. Try to understand what kind of structure is given. Don't directly start solving the question. That is one of the biggest challenge, biggest mistake you do during the exam. In fact, in test series also, I have seen many students. Let's say 5 by 5 matrix is given and you have to find the rank of the matrix, right? You guys directly start solving it. सो वेस्ट हो जाता है टाइम, आप सॉल्व ही नहीं कर पाते हो, ठीक है. तो 10 मिनट्स अगर आप ले रहे हो इस क्वेश्चन में, मैंने लिया था, सो आई एम जस्ट टेलिंग यू, राइट. एंड दैट वाज वन ऑफ द सिली थॉट प्रोसेस, ओके. बट ओवर द पास्ट 10 months आई हैव डेवलप्ड द टेक्निक दैट नो, दिस टाइम वी आर नॉट गोइंग टू रिपीट द सेम मिस्टेक. कहते हैं ना कि we try, we fail miserably initially when we try something out of the box, okay, but at times we might win also, right? So you see, consider the matrix 1k 2 1, where k is positive real number. Which one of the following vectors is our eigenvectors of the matrix? So if you choose k equal to 2, so this matrix becomes the symmetric matrix. And you know that there is a theorem called spectral theorem. What spectral theorem says that this spectral theorem is only applicable to symmetric matrix. Okay, so if the matrix is symmetric, remember this concept. If the matrix is symmetric, okay, if the matrix is symmetric, okay, so the calculation is going to become much simpler, right? You don't have to in fact calculate anything, you can eliminate options, right? If the matrix is symmetric matrix, so symmetric matrix have real eigenvalues and orthogonal eigenvectors, remember that. So the spectral theorem says that, spectral theorem, which is only applicable to symmetric matrix, what it says that the eigenvalue, okay, please do remember this point, okay, because in the gate examination they will give you question where you can solve in very less time. Eigenvalue are real and, okay, eigenvalues are real and the eigenvector must be orthogonal. Eigenvectors must be orthogonal. Okay, I hope this makes sense. What is the meaning of orthogonal? Let's say that x is the eigenvector, so x transpose x should be equal to 0. Okay, that is called orthogonal. Okay, now you can go to the option. Needless to solve this question again. See, if you choose these two options, okay, since it is a MSQ question and this is 2 mark question, you can say. So if you choose these two options, right, okay, if you choose these two options and try to take the, let's say this is a eigenvector, this is eigenvector, correct eigenvector. So if you take the dot product of these two, so you can say that 1 minus 1, okay, 1 minus 1, because k equal to 2 you have to put, right? K equal to 2 you have to put here, understand? Okay, so this becomes 1 minus 1, okay. So you have got 1 minus 1 and this is 1 1. These are the two eigenvectors. Okay. If you take the dot product of this, so 1 minus 1, which is 0. Okay, so these two options are going to be correct only. You can also verify these two. Okay, so if you take k equal to 2, means this becomes 2 1, and this is 2 minus 1. And if you take the dot product of them, so that becomes 4 minus 1, which is 3, right? Which is not equal to 0, means these two eigenvectors are not orthogonal to each other, right? So the options which are correct here is A and B. That's what I wanted to explain, right? So whenever in the question the matrix is symmetric matrix, okay, in the question, please remember, during test series you can check this concept. Okay, this theorem is very important, a powerful theorem, powerful tool to eliminate all those calculations that you have studied in the classroom. Okay, please avoid that. ठीक है, जब भी क्वेश्चन आएगा, consider the matrix. It can be any order, right? It, for the simplicity, they have given 2 by 2 matrix. They can give you 3 by 3, 4 by 4, 5 by 5. But as long as the matrix, the structure of the matrix you are able to identify, okay, and it should be the symmetric matrix, okay, then you can say confidently that the eigen values are going to be real, and their corresponding eigenvectors are going to be orthogonal to each other. And I believe this session will help you master linear algebra, okay, more confidently. You will be able to solve, okay, in gate 2025. So this session is not only important for electronics and communication, but for data science and AI, and computer science, electrical engineering, and for all the branch of engineering. We'll catch up in the next session. Thank you. Keep learning.